Today we discuss about error functions. The error function denoted by ERF of x or error function of x originated in the study of probability and statistics, especially specifically in the analysis of Gaussian or normal distributions. It was first introduced by Carl Friedrich Gauss in the early 19th century while studying the normal distribution, but it was formally defined and analyzed by John Carl Friedrich Gauss and Pierre Simon Laplace in the context of probability theory. The function gained prominence in mathematical physics, engineering, and numerical analysis due to its crucial role in error analysis, diffusion problem, and heat conduction. Now let us define what is error function. Error function of x denoted by ERF of x and defined as error function of x is equal to 2 upon root pi integration under the limit 0 to x of e to the power minus u square with respect to u. Similarly, there is a complementary error function. Complementary error function of x denoted by ER error function, complementary of error function, and defined as error function of complementary error function of x, which is equal to 2 upon root pi integration under the limit x to infinity e to the power minus u square with respect to u. So clearly, if we see the error function, the limit of the error function is 0 to x, and the limit of the error function is from x to infinity. Let us take some properties of error function. So the property number 1, error function of 0 is equal to 0. Let us try to prove it. Error function of x is given by error function of x is equal to 2 upon root pi integration under the limit 0 to x e to the power minus u square with respect to u. Let us put x equal to 0. So we have error function of 0, which is given by 2 upon root pi integration under the limit 0 to 0, because we have to put the value of x is 0, e to the power minus u square with respect to u. But we know that if any integral whose both the limits are same, then its value is always 0. So clearly error function of 0 is 0. Let us go to the next property. Error function of infinity is equal to 1. It means 1 means 100%. So let us prove it also. Error function of x is given by error function of x is equal to 2 upon root pi integration under the limit 0 to x e to the power minus u square with respect to u. Let us put x is equal to infinity. Then we have error function of infinity is equal to 2 upon root pi integration under the limit 0 to infinity e to the power minus u square du. Let us give it equation number 1. Now let us put u square is equal to t, because we want to integrate this part. So for that purpose, we have to put u square is equal to t, then 2u du is equal to dt, or du is equal to dt upon 2 root t, because if u square is t, then what is u? U is equal to root of t. So du is equal to dt upon 2 root t. We have to transpose this to the this side. So this is dt upon 2u, but u is equal to root t, so dt upon 2 root t. Also, when u tending to 0, t will also tending to 0, and if u tending to infinity, then t will also tends to infinity. Hence, the equation number 1 becomes error function of infinity is equal to 2 upon root pi integration under the limit 0 to infinity e to the power minus t dt upon 2 root t, because u square is t and du is equal to dt upon 2 root t. Let us simplify it. So 2 upon root pi, we can take 1 upon 2 outside, and this root t can be written as t to the power minus half e to the power minus t dt, which gives us 2 upon root pi into 1 upon 2 integration of t to the power half minus 1, because it is t to the power minus half, so we can write down half minus 1. Half minus 1 is minus 1 by 2. So this is t to the power 1 by 2 minus 1 e to the power minus t dt. Now, if we see this integral, this part only, then this is nothing but the gamma function, because gamma of n is equal to integration under the limit 0 to infinity x to the power n minus 1 e to the power minus x dx. So here, if we see in place of n, it is 1 by 2. So this is nothing but gamma 1 by 2. But we know that gamma 1 by 2 is root pi. Gamma 1 by 2 is root pi. So this total value of this integration of, this is very much important formula. Integration of e to the power uh, minus u square under the limit 0 to infinity du, its value is root pi by 2. So we should also learn this. This is a definite integral formula. Now, this root pi and root pi will cancel. This 2 and 2 will cancel. So we have 1. So error function of infinity is equal to 1. Let us see the property number 3. Error function is an odd function. That is, error function of minus x is equal to minus of error function of x. Let us try to prove it. So we know that the error function of x is given by error function of x is equal to 2 upon root pi integration under the limit 0 to x of e to the power minus u square with respect to u. Replace x by minus x. So we have error function of minus x is equal to 2 upon root pi, and since we are replacing x by minus x, so this limit will be 0 to x will become 0 to minus x and e to the power minus u square du. Now, if you put this u is equal to t, u is equal to minus t, then du is equal to minus dt. Also, when u tending to 0, t tending to 0, and u tending to minus x, if u tending to minus x, then t tending to x, because minus minus will cancel. So 1 becomes error function of minus x, which is equal to 2 upon root pi integration under the limit 0 to x e to the power minus u square, and this du will be replaced by minus dt. So now, if we take minus sign outside, it's minus sign, so which is given by minus 2 upon root pi integration under the limit 0 to x e to the power minus u square dt. And what is this? This is nothing but error function of x. So this gives us minus of error function of x. So this is called odd function. So I think we know that everybody knows that what is odd function. The function f of x is said to be odd function if for all value of x, f of minus x, f of minus x, which is equal to minus of fx. So this is called odd function, and if f of minus x is equal to plus f of x, then this is called even function. So error function is an odd function. Let us go to the next property. Error function of x plus error function of complementary of x, which is given by 1. Let us try to prove it. Error function and complementary error function of x are given by error function of x is equal to 2 upon root pi integration under the limit 0 to x e to the power minus u square du, and error function of complementary of x is equal to 2 upon root pi integration under the limit x to infinity e to the power minus u square du. Taking left hand side. So let us take the left hand side of the given property. Error function of x plus error function of complementary of x. So let us put the value of error function and its complementary. 2 upon root pi integration of 0 to x, integration under the limit 0 to x of e to the power minus u square du, plus 2 upon root pi integration under the limit x to infinity of e to the power minus u square du. Now we can take 2 upon root pi common, as this 2 upon root pi is common in both the part. So we have integration of e to the power minus u square under the limit 0 to x with respect to u, plus integration of e to the power minus u square under the limit x to infinity with respect to u. Now, we also know about one property of definite integral. If a to b fx dx plus b to c fx dx, integration of a to b under the limit a to b fx dx plus integration of fx under the limit b to c, then this is what we can, this is b is common in both part. So it can be written as integration under the limit a to c. So we can write down integration of f of x under the limit a to c with respect to x. So this can be written as 0 to infinity, 0 to infinity e to the power minus u square du. And in the previous property, we have already proved that integration of e to the power minus u square under the limit 0 to infinity with respect to u is nothing but root pi by 2. So we can directly put its value because we have already proved this result in the previous properties. So if this 2 will again cancel and we have the value 1. So error function of x and error function of complementary of x, which is given by 1. Let us take the property number 5, which is the series expansion of error function. Error function of x is equal to 2 upon root pi, and which is multiplied by x minus x cube upon 3 plus x to the power 5 upon 10 and so on. So we can write down error function in terms of series. So let us try to prove it. So we know that e to the power minus x is equal to 1 minus x upon 1 factorial plus x square upon 2 factorial minus x cube upon 3 factorial plus x to the power 4 upon 4 factorial. So let us just replace this x by u square. Then we have e to the power minus u square is equal to 1 minus u square upon 1 factorial, u to the power 4 upon 4 factorial minus u to the power 6 upon 3 factorial plus u to the power 8 upon 4 factorial. Now, we know that error function of x is given by error function of x is 2 upon root pi integration under the limit 0 to x of e to the power minus u square du. Let us substitute the value of e to the power minus u square from this expression. So this is 1 minus u square upon 1 factorial plus u to the power 4 upon 2 factorial minus u to the power 6 upon 3 factorial plus u to the power 8 upon 4 factorial and so on with respect to u. Now, if we integrate it, what is the integration of du? It is nothing but u. Integration of u square, it is u cube upon 3. Integration of u to the power 4, it is u to the power 5 upon 5, but there is a factorial 2, so 5 into 2 is 10. Then u to the power 6, uh, integration of u to the power 6 is u to the power 7 upon 7 into 3 factorial is 6, so 6 into 7 is 42. Similarly, integration of u to the power 8 is equal to u to the power 9 upon 9 into 4 factorial means 24. So 9 into 24 is 216. And there is a limit 0 to x. Now if we substitute the upper limit and lower limit, then we have 2 upon root pi x minus x cube upon 3 plus x to the power 5 upon 10 minus x to the power 7 upon 42 plus x to the power 9 upon 216 and so on. So this is the series expansion of error function. Now let us take some applications of error function. So the first application of error function is in normal distribution and probability. The error function is directly related to the cumulative distribution function CDF of the normal distribution and also used in statistics to complete probabilities in hypothesis testing. The second application is in communication system, or it is called beat error rate, BER. It is used to calculate the probability of error in digital communication. For example, BPSK and QAM. The third application is in heat conduction and diffusion. So error function solves heat conduction problems in a semi-infinite solid. The next application is in quantum mechanics. So error function used in solving Schrodinger's equation, particularly in potential barrier problems. Now the fifth application is in error propagation in experiments. So error function helps to estimate uncertainty in measurements by quantifying errors. The next application is in aerodynamics and fluid flow. It appears in solutions to boundary layer problems in aerospace engineering. In biomedical engineering and pharmacokinetics, error function is also used in modeling drug absorptions and diffusion through biological membranes. The eighth application is in financial mathematics. It appears in Black-Scholes equations for pricing stock options. Ninth application is in machine learning and artificial intelligence. It is related to certain activation functions like Gaussian activation in neural networks. And The 10th application is in image processing and computer vision. So error function is also used in Gaussian blur algorithm for image smoothing and edge detection. So these are some uh, applications of error functions. Thank you.